Welcome to the PQ-React Conversations with our experts, your decryption key to the future of cryptography. In this series, we dive into one of the most critical transitions of our digital age, the shift from classical to post-quantum cryptography. As quantum computing rapidly evolves, so does the urgency to secure our digital systems. My name is Marva Rabadzi, and I'm one of the Communication Dissemination Managers of the PQ-React project. Today, in our second episode, Powering the Future, Energy-Related Pilots, Infrastructure Readiness, and the NIST Standardization Journey through the PQ-React expertise, we welcome David Domingo from Indra. David is a senior engineer with extensive experience in designing and developing secure systems across multiple environments, including space, defense, and energy utilities. Without further ado, let's start. So, good morning, Adib, and thank you very much for being with us today.
Thank you very much. Thank you for giving me the opportunity to share the current status of our project and to explain why going to post-quantum crypto, starting now, is so important.
Okay, let's start with the first question. We know that part of your work involves following the NIST standardization process. Can you explain what this process is, why it's important, and maybe give us a concrete example of how it's connected to the work being done in PQ-React?
Yeah. The NIST PQC standardization process arises from the need to develop new cryptographic mechanisms not vulnerable to quantum computers. It is particularly challenging because these new methods usually rely on mathematics quite different from the current classical schemas. Even if we still don't know when a quantum computer will pose a real risk to current crypto, it is very important to start the migration to PQC as soon as possible, both for security reasons, but also to be ready to surpass the challenges that this new crypto will raise. One of our objectives in the PQ-React project is analyzing these challenges in environments where they might be especially demanding.
Perfect, thank you very much. So let's move to the second question. One of the PQ-React challenges is the assessment of the cryptographic components in existing technology infrastructures. Can you explain why this assessment is necessary and how it helps build migration roadmaps towards the post-quantum cryptography era?
Yeah. In order to start the migration to quantum-safe crypto, the first thing to address is to have a catalog of the algorithms protecting your system in order to perform a security analysis. Are these algorithms quantum safe or not? What is the required security level of these algorithms? What are the performance capabilities of the existing environments, etc. Provided with this information, an ordered transition can be planned.
So from your experience, which technology infrastructure or sector do you believe this kind of assessment is especially challenging or important, like healthcare, finance, or governmental, and why?
For sure, all of them are going to be impacted at some extent. Some of them will require faster migration because of the criticality of the information being protected. Others merely because of the technical challenges to overcome. The smart grid sector we are working with in the project is a very good example of a challenging technical environment. We are working with devices with very low processing capacity, networks with low bandwidth, very heterogeneous hardware deployments, etc.
Okay, so let's talk about the project pilots now. You're leading the use case on post-quantum cryptography for smart grid application. To help our listeners understand better, what exactly do we mean by a pilot in this context? How will this test be carried out, and what kind of outcomes are you hoping to achieve?
In the pilots, we resemble challenging scenarios in order to have some real sense of where the challenges will arise in real deployments. For instance, in the smart grid pilot, we expect to have metrics of the execution of post-quantum crypto algorithms in real smart meter CPUs. With this data, we can assess what algorithms are more suited for this kind of environments, or if some new hardware needs to be considered, etc.
Okay, and do you expect the pilot results to influence real deployments in the energy sector?
Yes, for sure. We are in contact with electricity utilities in order to collaborate with them, provide them with the results of the pilot, etc. In this way, we expect to raise awareness of the incoming challenges so as to speed up the adoption of measures and to foster easier and faster transition.
Okay, so we know today's episode touches on some very technical topics. So, to end on a more personal note, if you had one wish for the post-quantum era, what would it be and why?
I like that in the end, the process to develop and deploy post-quantum crypto not only strengthens our digital resilience, but also facilitates global cooperation and innovation, both in cryptographic research and implementation.
Okay, thank you very much, David, for sharing all these fascinating insights. We could easily talk for hours, but I think it's time to wrap up this episode. In the next one, we will dive into more topics and explore new themes around the post-quantum world. So stay tuned with the PQ React project and follow our journey on our social media platforms.